Hey, this is a quick little video to show some support of configurations in SolidWorks. I just created a video that focused on this simple 2.5 axis part, but it seemed like it would make sense to show how this could be leveraged in the context of an assembly, and then also show some 3D toolpaths. So I've got this part in the middle that's got some 3D toolpaths on it, as well as some true 5-axis toolpaths. So let's take a quick look at what I've done, and then we can work through the changes. So this first part has got a slot on the end, a slot in the middle here, 2D contour to do these side grooves. There's going to be some configurations of this part with the side grooves and some without. There's a chamfer that was added with a given clearance value from the walls and a series of holes. The number of holes is going to change on that particular part. On the next part, I roughed out with a shorter end mill. When I roughed that out, I enabled shaft and holder detection. So that's right here. So that takes the length of the tool into account and avoids any collisions. This is super important when the size of the part's changing. You want to make sure that you don't change the size of a part and then have the tool collide with it. So I'm enabling shaft and holder detection. And you can see that I generated a toolpath that machined everywhere it could while avoiding a collision. I then followed up with a rest machining operation with a longer tool. That tool also had shaft and holder detection on, but it came in and got at the stuff the shorter tool couldn't use. I've got a spiraling toolpath with slope confinement enabled. So on the geometry tab, I'm enabling slope confinement to find areas between 0 and 30 degrees. And then we're also keeping it off of that bottom floor so it doesn't machine that. So the slope confinement is another parametric way that just looks at the geometry regardless of what the geometry is. And lastly, I have a 3D contour operation. I took this one a step further. I've enabled slope confinement, so it's getting the areas that the scallop toolpath didn't. I've also gone ahead and enabled multi-axis tilting. This works very similar to shaft and holder detection that we've got here, but instead of trimming the toolpath away, in this case, it's actually going to do a 5-axis tilt on the toolpath. So if we look at a simulate at a point in time down the toolpath, we've started to tilt the toolpath away to avoid a collision. Now when we're higher up, there's no tilting necessary. Okay, so that's that part. If I go to the last part, I've got a swarf toolpath that's cleaning up around this outside wall. I'll do a quick simulate on that. So it's coming around this wall. And then we also have a pocket on the top. You know what, we should probably add a pocket to the side here too, so I'm going to go ahead and just drag a pocket out onto that wall. So we've got one on this tipped wall and around the edge. So what we're going to do is change the angle and the length of this part. We'll change the height of the middle part, and we'll change and suppress some features on the last part. So I'm going to switch back over to SolidWorks. It's the easiest place to do the configuration change. If you're using SolidWorks configurations, you know from assembly you can pick from the drop down. So let's pick a longer version of that part that has no cut. So that should update this part. Actually, I did a shorter version, sorry, but we've removed the cut, less holes now. This next part is actually an example of hundreds of configurations here. So I've got lots of options. I'm going to go ahead and in this case, let's pick a short version that only has 2 ribs. So I'm going to pick the 2-inch tall version. Let's do 2.5 inch tall version with 2 ribs. So we'll say OK. So now I have a 2-rib version that's short. And for this last one, I got a little lazy and I just did 2 configurations. So I'm going to do my default configuration that's going to be just a little bit longer. And you probably should have noticed that the angle is considerably shallower now. So we've changed the configuration of all 3 of those parts. We'll go to CAM, Naturally, the toolpaths need to be updated. Now, I could generate all of them at once, but let's just go through each of them at a time. So I'm going to regenerate the 2D operation. As we saw in that previous video, we've updated the ends, updated the slot, found the correct number of holes, and there was no toolpath in the case where that feature got suppressed. So when we post things out, there just would be no code. So that's all good. If I move to the 3D toolpath, we can now regenerate that. So I'm going to generate this toolpath. A couple of unique things are going to happen here. Pocketing operation will machine down. I probably should have picked an even shorter one because this still has some rest machining that has to get gotten. If I picked a shorter part, there'd be no rest machining at all. So let's go back and do that. Let's go from the 2.5 inch tall version to the 2 inch tall version. So this one's even shorter. This should better explain what's going on here. So let's regenerate this toolpath again. You'll notice that I didn't change the 2D part, so it didn't become dirty. Just the part that got dirty became dirty. So again, here we go. And now there's 0 toolpath for the shorter tool. So similar logic to when we suppressed a feature, that rest machining operation realized there was nothing it needed to do. So it's all taken care of. If we look at the toolpath that initially had some tilt, so the spiral toolpath got what it could get, contour toolpath got what it can get, and there's no need for tilt there. So now let's go to the last toolpath, and we're going to regenerate this guy. I'll get an updated swarf toolpath in a moment here. The pocket toolpath is already updated. Oh, I guess I didn't save that toolpath. I thought I put a toolpath on there. Oh, that's what I did. I put it in the wrong. See that I put it up in this other setup. So I'm just going to drag this this toolpath down into the correct setup. All right, now we can regenerate that. So we've got the 2 toolpaths and the swarf. So let's just do that one again so that we're sure that's working fine. So I'm going to go to this guy. I'm going to change back to the steep version of it. We're going to watch the part get steeper and shorter. I'll come back. I've got these 3 toolpaths here. I'm going to generate these 3 toolpaths. We're updating the pocket there. We're updating the 3+2 operation. And the swarf toolpath is going to take a moment longer. But we're going to calculate an updated swarf toolpath. So that's showing all 3 of them. Maybe we can do another quick change on this 3D one before we look at how the code goes out. So on the code on this one, let's pick some randomly taller one. So I'm going to pick my 4 inch tall by 5 rib configuration. And we'll accept that. So now I have my tall with 5 ribs. I'm going to come over to cam. I'll regenerate that toolpath. I'm going to just show while this is happening. I wanted to show you that we are using all of the cores of the computer, even in this case when there's only 2 toolpaths calculating. So it's not multi-threaded across operations. We're actually using all of the cores for even single operations. Okay, so it's just going to take a moment to calculate, but we had this pocketing operation and the rest machining operation, the spiral that gets the shallow areas, and the contour that follows up, again with the full amount of tilting. So let's just do a nice little simulate to see what's going on there. So let's play. We'll spin around, and then when we start to get into the need for tilt, the tilt is automatically applied because of the geometry. Okay, so now the next question has to do with posting. Can it be one program or multiple programs? This is the same as what happens always with HSMWorks. If I select all of, my apologies, I got these pop-ups coming, I should have turned those off. If I select the root file and I select post-process, now I naturally wouldn't do this in a situation, so if I select multiple setups and I select post-process, you wouldn't do this with 2 5-axis setups, but I'm simply making the point. If you select multiple setups, then we're going to post those together as a single NC program, except they're each at their own work offset based on what I did in the setup, a G54, G55, G56. We do have the option when we're posting multiple setups to reorder to minimize tool changes. So if I was using a 1/2" tool first on this setup, it would go and then use that 1/2" tool on the other two setups before doing a tool change. So there's some optimization we can do if we want a single program. If we want multiple programs, we just simply select one of the tool paths, and we'd select post process, and now we're just posting that particular setup. There is flexibility in the post processor, so if this is something you wanted highly automated, we could build a custom post processor that had some more logic in it and automatically split things up. But hopefully for now this shows how you can leverage multiple configurations, recalculate tool paths, and post out. The only add that they'll say, it's not sort of out of the box software, but we do have an API support. The API support is capable of regenerating and posting code, so you very potentially could leverage that API support to further automate things and have it select configurations, recalculate a tool path, and post things out. I hope that was a help. I'm happy to share this file. I suppose I should save it if I'm going to share it. So I'll save this file out. And actually, before I do that, quick little SolidWorks trick. I'm going to be cheating, and I'm going to make all these parts virtual, so that it's a single assembly file to share with you. So I've got all these virtual components. I'll save this and send it. Feel free to reach out if you get any more questions. Cheers, bye.